Great. All right. So thanks everyone for taking the time to join us today for this webinar. So my name's Pat. For those of you that just came in, I'm one of the application engineers with the team. And today what we're going to be running through is our digital tools and how to use your energy data. Okay, so I'll jump into that. Okay, great. So we have this vision, 24 hours of sun. Some of you may be familiar with it. Some of you, it might be the first time that you're seeing this. But what is 24 hours of sun? It's a world where 100% of our energy needs are met by renewable sources, right? And this can't just be done by us alone. It's a collaborative effort. So, Fronius is, always open to working with other manufacturers and other, stakeholders and players within the industry to get towards that goal and complete that vision, right? So you can see there's wind in the background. We have hydro over here. We, of course, have solar PV, which we're heavily involved in, invested in. And we also have hydrogen as well, which we're starting to do a lot of work with as well, and we think it's going to be a big part of the solution. So, as I said, it's a collaborative effort. We can't do this by ourselves, and we need to work together to get there. So, in terms of getting to that goal of 24 hours of sun, we have these three pillars, right? So that is future-proof and flexible, reliability, and optimization. Right. So when we look at the future-proof side of things, we want to make sure that our inverter will be able to meet the needs of the future. So you don't need to constantly replace it. Then in terms of reliability, when it's out there, you want it to be performing well. The more reliable the inverter is and the system is, it's easier the life for the installer, but also means a better overall uptime for the system for the customer. Okay. Then optimization, that relates to a few things, including reducing the amount of time that you spend on site. And there's a few ways that we're able to optimize our products. But in terms of what we're focusing on today, it's about optimizing that energy usage. And I'll touch on this a bit later on. So looking at that first pillar, future-proof and flexible. So if you consider our snap inverter, which you can see here in the middle, right? So that was an inverter that was designed almost 10 years ago, yet it's able to cope with changing requirements, right? So we want to make sure that we can adapt and be able to fit in with these changing needs of, say, DNSPs. So say the volt var settings is an example of that. And we want to be able to comply with future regulations, right? So there's no need to make significant changes to the inverter, it's already there. Then in terms of flexibility, that's also important. So we have our Superflex design, so meaning that you're able to do lots of different designs with the inverters for different roof orientations and things like that. Then we have our data manager card. So this allows for third-party communication and also to monitor the PV system. And we're part of this SunSpec Alliance, right? So, that's aiming to increase integration between different devices, different manufacturers, and it goes hand in hand with the open interfaces that our data manager card has, right? So as I said, we have that vision of 24 hours of sun. And in order to accomplish that, we need to be collaborating, as I said. So this SunSpec Alliance, and having these open interfaces to make it easy to talk to other devices, that's also quite important. So looking at the data manager card, right, so the data manager card 2, this is built into our inverters. It logs production data. It has various open interfaces to allow communication with other devices. Also, you can have a smart meter attached, which we'll go into in a little bit. Sometimes people want to extract data to use with their own software. So this can be done, for example, through our APIs. It's also able to do export limiting. There's quite a few sites out there that require that. So no need to get anything else. You've got that within this monitoring card. And then it also alerts you if something is amiss. If it's connected to the internet there, you can get these alerts as well. All right. So there's a few different things there. You're also able to do some energy management stuff that we'll touch on a bit later on. So, that leads us on to a question that we get, why monitor at all, right? So there's benefits to the customer if the system is monitored, then they can get more information about their energy profile at their premises. They can inform them about how to manage their energy, how to use their energy in the smartest way possible, right? But also for installers, it's really important because it means that you can diagnose any problems. If you say you get a call from a customer, you can see the system online and go through certain details, which we'll cover during this webinar as well. And with certain situations, you can even resolve things without having to go to site. And it's also easier to navigate conversations with certain customers. I've heard this a few times where a customer will call up after their system has been installed, and they'll say, look, my power bill's not going down. Now, if you have this detailed information about how they're using their energy or the energy profile on that site, then it's a lot easier to navigate those conversations. And with a smart meter, you'll have more information. So I'll touch on that in a bit. So that's one thing or a couple of things on why to monitor. But also you'll find that data has this dollar value, right? So the data that's being collected has a dollar value, and we'll touch on that. We'll touch on that later on. But in terms of what's happening right now when it comes to installing a system, right? So there's some normal steps, I guess, that all installers will follow, and where they usually get to is here, right? So this is the general series of steps. So they'll plan and design the system, then they'll go and install the system, right? Then they'll register the warranty for the system. They might do some service and maybe just get it online and have it the monitoring set up, right? Not everyone's doing this monitoring step, but even if they are, a lot of the times we'll just stop here, and that's the end. That's the end of it, all right? So there are things that you can do if you are monitoring the system, and it means that you can provide some more value to your customer and also come back to them, all right? So we'll get onto that, but before we go into that, I wanted to talk about how this data that's being collected, this monitoring that you're doing, right? How it's actually visualized, because when we consider our digital tools, and a big part of those digital tools is Solar.web, our online monitoring platform, right? That's one of the primary functions there, to be able to visualize data and also to extract that data. So looking at Solar.web, so this is the dashboard of Solar.web, right? So you can see here, there's a bubble chart up here, right? So note that you wouldn't see all of this if you didn't have a smart meter, right? So in this case, there's also a battery, which wouldn't be there. But if you didn't have a smart meter, it would just be one circle showing you how much you're producing, right? But with the bubble chart, if you did have a smart meter attached, you can see this information. And those little bubbles here will be moving in a certain direction. And the way that they're moving, that direction, the way the circles are moving, is the direction of the power flow, right? So there you can get a snapshot of what you're producing, right? How much you're consuming, what's being fed into the grid or what's being imported from the grid, right? And then some information about the battery as well, right? So what it's potentially taking in to charge, right? Then you have this energy balance snapshot here. So the gray bit is when you're taking energy from the grid. The yellow bit is when you're feeding it into the grid, right? And then you have your earnings up here, right? So calculate on the tariff settings you enter. It gives you a bit of information on the customer's return on investment, right? Then you have your CO2 savings here, so you can see, what impact, I guess, you've had there in terms of reducing emissions on the environment. And then you have a picture, you can put in whatever you want, and the weather forecast here down the bottom, right? So that's the dashboard. So you can get a quick snapshot of some data there, right? Then if you go into the energy balance tab, so you can either click here or you can click on this graph as well, it'll take you in. And you'll get to this page here. So there's two different ways of viewing the data, right? Production and consumption. So I'll come to that in a second. But here, the difference that you can see right now with a smart meter versus without a smart meter, right? So without a smart meter, you can just see what's being produced, right? But with a smart meter, there's a lot more data that you can get, right? So you'll be getting 5-minute incremental data in the daily view. So this is in the daily view. You also have monthly and yearly and total. But in the daily view, it'll look something like this, and you can get 5-minute incremental data, right? So as I said, you've got the production view here, consumption view here. It's just two different ways of viewing the data. So you can see over here, you know, power to grid is shaded in gray, power going to the battery in green. Your consumption is that blue line, and whatever is shaded yellow is what you're consuming directly, or so what you're consuming from your solar system. So here, for example, this yellow bit is being taken from the solar system. The rest would be taken from the grid, for example, right? So quite a bit of data that you can see there. So that's the daily view. And then you can also have the monthly view. So you get daily totals, right, for each day. So you can see there energy to grid, energy to battery, and consumed directly, for example, right? So you're getting those totals for each day. And then if you click on the yearly view, you'll get totals for each month, right? So that's another way to visualize it. And then you can also click on the total tab here, which would give you totals for each year, right? If you want to see that. Another way you can visualize data is to go into the analysis tab. So if you click up here, right, even more data can be viewed. So it'll take you through to this real-time tab. You can see how much your inverter is producing in real time, right, and what its performance is. And then if you click on history up the top here, so you can choose your device. So you can either choose the meter, or you can, if you had a meter there, or you can choose your inverter. So I've chosen the inverter, right? And then you can select different parameters that you want to look at. So here we've got the current and voltage on the first phase there, right? And then if you also wanted to, what you can do is you can look at things on the meter side, right? So you can select that and look at various data that the meter is seeing, okay? So quite a bit of data that you can visualize between the analysis and the energy balance views, right? Or those sections within Solar.web. And another thing you can do is you can also extract this data into a report, right? If you need to do some analysis on it, some further analysis on it. Or some installers will have to do certain reports for their clients, etc. So you can do this by clicking on reports, right? Create a new report. And then if you don't have a smart meter, you wouldn't have that energy balance option. You could only do a report in PV production. And then you can also do some custom reports as well, where you can get a lot more parameters as well, right? So PV production is, what's being produced. Energy balance will show you things like what you're consuming, what you're producing, etc. And then custom reports, you can have a variety of different parameters there. All right, so there's quite a lot of data that you can extract, as you can see, and you can use this data to troubleshoot with certain aspects there when you're talking to customers. But there's also different ways that you can use Solar.web to assess system health, right? So, is the system performing the way you expected? I alluded to the conversation at the start with the customer saying, the bills aren't going down, etc. So seeing exactly what they're consuming and when they're doing it, etc., makes it more easier to see if there's actually an issue, right? But there's also these other tools as well. So if you go into service messages right here, right, there's a log of all the service messages, state codes that appear on the inverter that you can look at, right? So if you click on service messages, you can set a date range up there, and then you can see any service messages that have been received for that particular system, right? Then you can also do remote updates. So if you go into settings, right, up the top there, and then go into components, right, you can see that you can update either the data manager card software, or you can also update the firmware on the inverter as well, right? So a lot of issues can be fixed this way, and it's something that can be done remotely, right, without having to go to site. Then lastly, going back to that analysis tab, right? So in the history view, I told you before how you can get up, various information for your inverter, also the smart meter as well. And this can also be used to troubleshoot and diagnose some problems there, right? So, there's certain examples like, if the inverter, say for example, was derating, you might go to site and then you might see that the AC voltage there was the cause of the issue, right? Or maybe the site was not producing enough, and then you can check the DC parameters, and in one case there was no DC current. So things like this, it can help with that preliminary troubleshooting and pinpointing towards possible causes of what's going on, right? So you have all this data that's available with Solar.web, right? And what that data can be useful for is future-proofing the system, right? So I was talking about data having this dollar value, and this relates to how the data can be used to future-proofing a system, right? So as I was saying before, at a couple of points, if you have a smart meter, then you're going to get more data, right? And with that additional data, it means that you're better off for future-proofing the system, right? So we always encourage customers to install a smart meter so that they can analyze their electrical consumption, right? So that they can be smart with their energy. With the smart meter attached, you get more in-depth information. Are they using a lot of power from the grid? When are they using their power, etc., right? And when you have more knowledge about the system, right, you can define loads. And the advantage there is that you can start to do energy management. So you can divert excess power, say, for example, to a pool pump, things like that. And then if necessary, you can also store surplus energy if you think that that's the best way to go about it, right? So, with the energy management function, there's, customers can make decisions on the best way to manage their energy and whether they, possibly need to expand their system. If they're thinking of getting, an EV, for example, with this information, they can also do it efficiently in terms of charging, discharging, etc., and making the most out of their system, right? And then if they have to look at storage, this will better inform them as to how they go about that. We'll touch on that later on, right? So the more amount of data that you have, the higher the dollar value, right? You can learn a lot about the system from having this data. You can also monitor individual loads if necessary with multiple smart meters to get a very detailed picture. When is this load kicking in? When are they using that load most of the time, right? But you can also get a lot of information just from one smart meter, right? To see what the overall load is on the site, right? And it's important in the future when you think about getting a battery, for example, if that's really the step that you need to take at that point in time, right? So Dan will cover that in in a bit later on. So here you can see once you've got, sorry, my pointer wasn't working. Sorry, it's just jumped across. Okay, so here you can see when you've got a smart meter attached, you can start to do things like optimizing the system with energy management and getting the customer to make the most of what they have, right? So you can go back to the customer and say, hey, I can see that you're using a lot of power at this point of the day consistently. Do you know what's turning on? It might be a pool pump or a hot water system. And then you can, depending on the circumstances, you can upgrade the system by installing a contactor, which can be used to control the load, switch it on or off using our free energy management software, right? So how do we go about that, right? So if you have, say, a smart meter, right, it can tell you how much power you are exporting to the grid, how much excess power you have. And then you can control up to 4 devices or 4 different loads via 4 different contactors, right? And these can switch on or off depending on what parameters you set. It's just a 12-volt signal that gets sent to turn them on or off, right? So there's a number of different possibilities. In this example, there's like a cooling or air conditioner unit. You've got a EV charging station, a heating element, a pool pump, right? So 4 different contactors attached there, right? And you can say which one you want to turn on first, right? So if I have excess, turn this one on first. If I still have excess, then turn on this one, for example. If I still have excess, then the next, and so forth, right? And the thing here is to make the most of what you have, increase that self-consumption, right? So some installers will already know, from the conversations they've had with the customer, how they're using their power. So they might set, 1 or 2 or so of these contactors up when they install the system to divert that excess power. But otherwise, you can monitor the system for a bit and then come back to that customer. All right, so here's an example here. So you got to set your priorities here. So you might put battery as number 1 if you had a battery. So if I have excess, charge the battery first, and then from there, if you still have excess, then start doing energy management via these contactors, right? So in this example, there's a pool pump, right? And it's 1200 watts there. So it's saying when I have a power surplus, turn this load on, right? So you're doing it by power surplus, and you're saying do it when there's 1200 watts getting fed in, right? So you can define this excess power, right? So here it's 1200 watts. When I have excess of 1200, switch this load on, right? When I'm not using anything from the grid, turn off, right? So you can do different things there, whatever you want to set it as, right? You can also do it by power production, but here, if you have a smart meter, you can do it by power surplus there, right? Then you've got these durations here. So every time I switch on, make sure it runs for 15 minutes. So some devices out there don't like to be turned on and off. It can damage the appliance. So you can put a minimum runtime in there every time it switches on, right? Then you can also put a maximum duration per day. So, no matter how many times it turns on, I only want it maximum to run for 480 minutes, right? So you can put that in as well, right? And then if you want to make sure that this load works for a certain amount of time per day, you can stipulate that. So in this case, it's 240 minutes. So by the end of the day, and here it's set to finish by 6 o'clock. So by 6 o'clock PM, I want this load to have run for 240 minutes, right? So that's regardless of, if there's solar. So perhaps if it was a particularly cloudy day and there hadn't been much solar produced, right? So, there wasn't much PV, then before 6 o'clock, it would work out that, okay, I need to switch on and run for this duration to make sure that I've done 240 minutes by 6 o'clock. All right, so there's quite a lot of ways you can configure this energy management function. It's free. That relay, it only costs about $60–70. So quite a cost-effective way for the customer to get more out of their system there. And by doing this, you then complete you can complete this cycle, right? So you can do optimization, energy management, etc. You might need to increase the amount of panels on the system, right? Or it might be time to add on a battery, right? Or do some storage solutions. So the more data you have, the more informed your decision will be, and how you can advise the customer, right? So before we go into our storage solution, though, we want to touch on some of the storage basics. And one of those things is self-consumption versus self-sufficiency rate. So I'll hand over to Dan, who's my colleague, who's also here, and he'll be taking you through this section and our storage solution as well.
Okay, thanks, Patrick. Hi, everyone. Apologies about the technical glitch earlier. For some reason, I wasn't able to join the webinar at the start, but it's great to be here. And Patrick's gone through some great info there on how to use Solar.web. So I'm just going to cut across to my screen. So for those of you who don't know me, I'm the Queensland rep for Fronius as an application engineer based up in Brisbane. So I've recently started with Fronius, and thanks all of you for joining us. It's great for you to join us this afternoon, and I hope you're all doing okay out there. And if you're in a place that's in lockdown, I hope you're coping okay with that. So hopefully you're all able to see my screen now. I'll just check with Patrick. You able to see my screen?
Yep, all good, Dan. All good.
Okay, great. So as Patrick was talking about some of the features there on Solar.web, I think this is something that can really benefit your business by not just by potentially saving you time in troubleshooting. It can also value add to your business in the eyes of your customers, especially when you start doing things like energy management. And if you add the bits of hardware like the smart meter, then you're able to potentially get more repeat business with your customers. So, and also the great energy management functions that we're talking about, prioritizing loads. This really helps out in the customer's self-consumption and utilizing all their PV power during the day. So the other term we talk about is when we start to look at energy storage is self-sufficiency rate. So difference there is self-consumption is just your daytime power use, and when we talk about solar power, trying to use as much of it as possible. And self-sufficiency is looking at the full 24-hour period. And there's another great term that's very similar called energy independence. And a lot of customers love to talk about being independent from the grid and getting away from their electricity retailers. So just to cover a bit more on self-consumption, I'll just show another of those slides that Pat had from Solar.web, and he was talking about this, and this is the example of where you're looking at your consumption during the day. And the difference between this, as I mentioned, with self-sufficiency is when you start to look at your nighttime usage. And a lot of customers, when they see that during the day they've got a lot of excess PV power, they want to be able to utilize this as well, rather than just send it back to the grid. So that's when, obviously, it's a big topic, batteries and energy storage. How do we utilize this, and what's the best way to do it? So customers will want to know what's the best size battery for them. And another great tool we've got in Solar.web is the simulation tool. So I don't know how many of you guys have already used this or seen it within Solar.web, but you simply just go into, click on the analysis tab within Solar.web, and that'll take you through to a page where you'll see the simulation tab on the right hand side. And if you click on this, then you're in the simulation tool. And as you can see in the simulation tool, this will enable you to select heating or storage. The heating sections there just for the Fronius Iron Pilot. It shows you what you can get out of just adding the Iron Pilot and using that for your excess PV power during the day. But most people are interested in the storage function on your Simulate tool. So if you click on storage in the Simulate tool, it then takes you to this page. And you can see on the left there, you've got the self-sufficiency graphs. And when you select a battery and click on Simulate, this does a calculation based on the customer's PV production and also their consumption. So you do need a smart meter to be able to use this function. So to any of your customers who have had a Fronius system with a smart meter installed for a while, you'll be able to utilize this Simulate tool with them. And all you simply do is click on a battery, and this has all the different BYD battery types that are compatible with the Fronius Gen 24s. And then once you select a battery and hit the Simulate button, what this does, it does the calculation in the background and tells you the self-sufficiency rate. And this will enable you to propose to your customer the best size system that they need for their battery. The screen on the right is exactly the same as the one on the left. It's the same battery, it's the BYD 6.4 kilowatt hour battery, but what they've selected there is the backup mode option. And this is leaving some reserve in the energy storage in the event of a grid failure. So if you have a blackout, you have that reserve power there left in the battery. And what this will do is make sure that they've got some power when the grid goes down, but it does reduce the self-sufficiency rate a little bit because obviously you're not able to use that battery storage that you've got there as it's kept in reserve. But you might think that by just clicking on the biggest battery, this is going to give you the best self-sufficiency rate. Well, that's not necessarily true. As you can quickly figure out, if you don't have enough solar PV, you're not going to be able to charge that battery. So by selecting different battery types in the Simulate tool and just trying a few different types, you'll see that self-sufficiency rate change, and you'll get to the point where you keep selecting bigger batteries, but the rate doesn't increase. And this is because you've hit the limit of where their PV power is able to charge that battery. So when you get to this stage, you've got two options where you can either recommend they stay with the smaller battery size, or it also might give you an opportunity for some repeat business there to tell the customer that they need some more solar power if they want to increase that self-sufficiency rate even more and be even more independent from the grid. So once you've had this conversation with your customer and you've put the proposals to them, then you can start talking about Fronius's Gen 24 product, which is our great hybrid battery storage unit. So a lot of you guys have probably all seen this inverter. It's been around for a little while. This is now the new flagship hybrid battery energy storage product. It's the all-in-one unit from Fronius. So I was just going to go through some of the info and some of the specs on the Gen 24 for those of you who might be a bit new to it, as this is, as mentioned, the flagship product for Fronius for energy storage. All right, so we've stuck with the names in the Gen 24 unit of SIMO and PRIMO. So I've got the versatility there of SIMO being the three-phase unit and PRIMO being the single phase unit. So in the SIMO range, you've got the 6 to 10 kilowatt hour models are going to be the most popular in the 3-phase range. And in the primos, at the moment, we've got the 3 to 6 kilowatt hour models in the primos. So all Gen 24 pluses are compatible with BYD batteries. So there's the HVS range and the HVM range for BYD. So Fronius decided to pair with BYD because they saw BYD had a great solution here for residential energy storage. They have a true high voltage battery that is very modular, it's easy to install, and it means that you're able to get the exact right size energy storage that your customer needs. And the technology they're using is the standard lithium iron phosphate, which it's a very safe technology and it's proven to be very stable. And you know, it's a long-lasting battery storage technology. So with the HVS, you can see there it's you can stack up to 4 modules high with the HVS range in 2.6 kilowatt hour steps. But if you go to the HVM range, you're able to put up to 8 modules high. So this gets you up to 22 kilowatt hours. And you're also able to stack up to 3 lots of BYD batteries. I'll get to that in a second, but this cheat sheet here, this is just simply a bunch of numbers showing you the instantaneous power ratings you'll get out of each different BYD battery. So what it means is each module you put on the BYD battery is increasing the voltage. So that means you're able to get more power out of that battery stack. So for example, if I have a look here, say at the HVM 13.8, across here on the even on the SIMO 10, it's still at 5.6 kilowatts instantaneous power. That's due to the voltage, but as you stack more modules on the HVM range, you get up to the 22 kilowatt hour module size with 8 modules, then you're able to get 9 kilowatts out of the battery at any one time. Yeah, and as I mentioned, you're able to actually put 3 stacks of the BYD batteries onto one Gen 24 to increase your energy storage even further if the customer decides they need more energy storage. So you've got lots of options there, and this is showing that when you go to 2 or 3 stacks, you can really have a lot of energy storage with the BYD batteries. All right, so when Fronius developed the Gen 24, they developed it with high efficiency in mind. They wanted to get the most efficiency out of those batteries when supplying the loads. And so they came up with this multi-flow technology, which simply means that it's a DC coupled style of charging to the battery straight from the PV array. And it can also supply the loads at the same time as charging the battery. So if the grid goes down, you're still able to charge the batteries from the PV array, and you're able to supply the loads as well. That's in the full backup mode. I'll go into that in a bit as well. So with the multi-flow technology, if you've got a customer with an existing Fronius inverter or even some other brand of inverter, you're able to add on the Gen 24. It can be AC coupled as well. So it'll utilize that excess AC power to charge the battery. And this can be done without even putting PV on the Gen 24. But if you put the PV on the Gen 24, you're going to get that advantage of having the high efficiency in charging with a DC coupled style in the multi-flow technology. So because Fronius has developed the Gen 24 with high efficiency in mind, they've done really well in some independent testing. So this graph here is from testing done by HTW Berlin University over in Germany. They test a number of hybrid systems every year. And as you can see in 2020, the SIMO Gen 24 came out as the most efficient system tested. And this is the overall efficiency or round trip efficiency, where how much losses you have to charge the battery and then supply loads from the battery. And then also there was some more testing done this year with the Primo Gen 24 being the single phase. It's not quite as efficient as a 3-phase, but it's still up at 92.2%, and the most efficient system they tested out of all those other hybrid systems tested, you can see in the graph. And having this high efficiency is going to mean you're going to get more yields for your customer, and they're going to get a better return on investment from their battery storage. All right, so another great feature of Gen 24 is you've got 2 options for backup power. Most people, when they talk about adding batteries, they really want to have backup power as an option on that system. So Fronius has come up with a great inexpensive backup power option where you don't even need to have a battery to get some backup power. And this is going to be a great feature of the Gen 24s because it's a very inexpensive option in giving the customer a little bit of energy independence. If the grid goes down, they're still able to get a bit of power out of their inverter. So this basic backup power option we're calling PV Point. And the way it works is you simply have a secondary AC output inside the Gen 24, and this AC output would be wired directly to a power point next to the inverter, and the customer is able to get some power. So the power they can get out of it is obviously going to be dependent on how much the sun is shining and how much solar PV power there is if they don't have a battery. But with this backup connection, it does automatically switch over when the grid goes out. So with PV Point, it's not active when there is grid mains power. So it only automatically connects when the grid shuts down. When you lose mains power, it takes about 45 to 60 seconds to change over, and it will power up as long as the sun's shining on the PV array. So it'll supply up to 3 kilowatts single phase only, even with the Simo Gen 24s. PV Point is a single phase power point. So this gives the customer a really inexpensive option for a bit of backup power, as it's a pretty straightforward install. The other option you've got, I'll just go through this graph just showing you how it works with PV Point. When the grid goes down, if you've got the sun shining, you're still able to get a bit of power out of your solar panels, and after about 45 seconds, it'll change over and supply power through to PV Point. And it can work with the battery as well. So you can use PV Point with the battery, and this is obviously going to mean it's a more reliable power source, having to been able to use the energy storage as well. There you have it. That's the PV Point option for backup power. The second option you've got is to go to a full backup power option. In the event of grid failure, you can have maximum backup power where you back up certain circuits in the house, or you could potentially even back up the whole house, depending on what the loads are within that house and what size system they have. But it would be possible to back up the entire house because the relay, the contactor, is external from the Gen 24. So you can select like a 63 amp contactor so that it's able to switch over the whole house. So the way this works, when the grid goes down, then your backup switch is going to disconnect the Gen 24 from the grid. So you can go into island mode, and it's going to supply power from your PV array. You can still charge the battery and supply the loads at the same time that are connected on that essential circuits. So this is your second option for backup power with the Gen 24. And for more information on this, please contact us if you want to get the guide on and the wiring diagram on how to set up the full EPS switchover setup for the full backup option. All right, so just getting back into Gen 24 and the digital tools that you have with Gen 24 and through utilizing Solar.web as well. It's got some open interfaces on it, like the snap inverters. It's able to be used and easily integrated into third-party devices, such as home automation systems or perhaps an EV charging station that a customer has. You'll be able to utilize the open interfaces on Gen 24 so you can increase the customer's self-use. The standard interfaces that Gen 24 has is obviously your Wi-Fi and Ethernet connections. And then you've also got 2 Modbus connections on the Gen 24, whereas the snap inverters only had the 1 Modbus circuit. The Gen 24s have 2. And you've also got the digital inputs and outputs for the Gen 24, the same as the snap inverters. And this can be used for all the energy management functions that Patrick was talking about, where you're able to prioritize loads and switch on and off some relays so you can really maximize that self-consumption. And there's also the option of the Fronius Solar API, which is where you can start to integrate with third-party devices like a home automation system. And that's another way to maximize your self-use. Yeah, and as we've been talking about a lot, there's the great energy management function on the Gen 24 as well as the snap inverters. All right, so you've got the top system monitoring of Solar.web, where you're able to utilize all the data you're getting out of the inverter, especially if you install a smart meter. As we move towards an energy storage industry, we highly recommend that all Gen 24s go in with the smart meter to future-proof your system. It's really going to help you to maybe get that repeat business with the customer. And the Gen 24 is designed as a hybrid inverter. So you really want to be putting in that smart meter to utilize all the functions you can get out of it. Okay, guys, well, that's just about it for covering some of the functions and features of the Gen 24. Yes, it's a new product. It's the flagship from Fronius. That's going to be the all-in-one solution for energy storage systems in the future.
As I said, if you do have any further questions, pv-solutions-australia@fronius.com is where you can send them to. And yeah, until the next time, keep well, keep safe. Just switch on my camera. Yeah, hope you're all doing okay out there. I know it can be quite tough, especially for those of you that have gone through extended lockdowns. Like I'm in one myself right now, so I can relate. But yeah, take care of yourselves, keep safe, keep well, and we'll see you next time. All right, thanks guys.
Thanks all.
Bye.
Thanks for joining us. Have a great afternoon.